Hi there, I'm Kenichi Vanisi, and I'm a graduate student at WPI, as well as a member of the WPI Robotics Resources team. And today I'll be leading you through the first introductory lecture to the robotics course for the MS for SSA, which is Math and Science for Sub-Saharan Africa project. I'm very excited to be able to introduce you to the wonderful and exciting world of robotics. All right, let's get right into it. In this introductory lesson, we will be answering the interesting question, which is, what is a robot? What are the characteristic features of robots? And what are robot systems that are available, or examples of robot systems that are available in the world today and around us? Then we'll think about why it is useful to learn about robotics and some of the neat applications of robotics. We'll then unpack the robotics subject by exploring what the main areas of robotics are. Finally, I would provide some context regarding what's going on in robotics in Africa today and how interesting programs are inspiring students and making a difference with robotics education today. So what's a robot? We can see so many different example pictures on the screen. Are they all robots? And how do you identify a machine as a robot? What are the characteristic features that define a robot? So here we have a standard definition for what a robot is according to the Robot Institute of America. And this definition is quite long, but the important aspects to note are that robots can be programmed for multiple functions, and they move themselves or other objects, and that the goal is to perform a given task. And the way we like to describe robots here at WPI is that a robot must first sense, think, and act. Sense means to observe and collect information from the environment. Think means to process this information collected from the environment, and act means to perform some action or carry out some programmed task based on the information that has been processed or programmed. Hence, for it to be a robot, it must sense, think, and act. So here are some interesting examples of robots that exist today. And let's try to see how they may perform the basic functions of robots that we've defined. So the first is the NASA Curiosity robot. And this is a robot sent by NASA to the planet Mars for space exploration. The robot moves around the terrain on Mars, collecting all sorts of data, and sends them back to the base station on Earth. Is this a robot? How does it sense? To take a simple example, it uses cameras to collect visual input, then thinks or plans as to what path to take to go from, say, point A to point B while exploring Mars. Once a plan is defined as to a path, it uses its motors to move along the ground. Now, how about B? This is a bomb diffuser robot. Bomb diffusing is dangerous, and so robots have been built to perform this task. And this robot also uses cameras to sense the environment as the robot moves towards the known bomb. Now, this process is often remote controlled by pressing in a secure location. But we can also see how sensing, processing, and acting in terms of diffuser of the bomb is applied also on this robot. Now in C also, we see a robot that has the form of a human being. Now this is the Baxter Industrial Robot. It has two arms, which can be used to pick and place objects. This robot may also use cameras to sense the position of an object to be picked up, and then may also use force sensors in the hands uh, for some grasping feedback. It needs to plan how to pick the object and where to place it. Once a plan is defined, the robot has to move its arms to complete the task. Finally, we see in D a very common type of industrial robot, which is used for welding. This robot needs to sense the location of the object to weld and then plan how to weld accurately before the welding actually begins. So we see in all these examples, generally speaking, that robots always perform the basic functions of sensing, planning, and then acting. So what are other examples of robots that you know? Well, we also have aerial robots, which are able to fly and have been used for applications from security to delivery of packages, even in Africa. And we have medical robots, which can be used to perform surgeries on patients, which is very interesting. And also, we have a lot of domestic service robots as well. And this one in the picture is a floor cleaning robot. It moves around the floor and cleans it up. So here are some examples of cool robots in action. And first we have the Atlas robot. Now this is a human-like robot design which can operate in normal human environments and perform various tasks like humans. And so here we have the robot walking in very uneven terrains, uh, like here in the snow, which is very difficult even for humans to do. And then also we have here showing the robot lifting up objects of various weights. And then here we have the robustness of the control of the robot being tested. And so we can see the robot is able to maintain posture. You can see how interesting that is, that the robot is able to sense the environment, plan what kind of motion to perform to complete the task, and then can actually control the upper and lower limbs like a human would to complete the task, which is really interesting. And then second here, we have a mobile robot which autonomously collects cubes on the floor in the workspace. And we can see it moving around, using its cameras to identify the location of the cubes, and then moves there and picks it up with the arm. And so we can see what kind of interest, and then it places it on the back there. And so we have here a mobile robot which performs some autonomous picking and placing of objects. And so in this case, it's picking or collecting this colored cubes that are in the workspace. And so the robot uses cameras to identify the location of the cubes and then moves there and picks them up with the arm, as we can see. Scanning the environment to find the next object. Then once it identifies it with its camera, you can see it moves towards that location. And so you can think about different kind of applications that robots can be used with all of this kind of process, which is sensing, thinking and planning, and then acting. Well, I hope that by now you are excited by some of the examples of robots that we've seen. But I'd like you to think more broadly about why we need to learn about robotics and how they can be used to improve the quality of life. So we have many robots performing a wide range of functions in different areas of life, like in the case of manufacturing, in the case of healthcare, in the case of agriculture, and even in the case of security. And the list never ends. Robotics is being applied in so many areas, and it is our hope that as we study robotics, we'll be able to think up new ways to apply robotics and automation to solve our local problems.